Now let's drive the second formula for the Karl Pearsons for the finding the coefficient of correlation, and in this formula we are not using deviations from the mean. So let's drive the result. Now just check it. We are having a term summation for xi minus x mean whole square. Now expanding this, we are having xi square twice of xi x mean plus x mean whole square. Now this will become xi square twice of with x mean plus n times x mean whole square. Here we have just expanded it. Now this becomes twice of xi plus n upon n square. X mean is what? Summation of all the terms upon total number of the terms. So here in this place I have used this part, okay, in x mean here and x mean here. Is it clear? So now what we are getting? We are getting now twice of whole square upon n plus whole square upon n. xi minus x mean whole square, to this we can write it xi whole square minus 1 upon n xi whole square. Here summation of xi whole square, here it is square of the summations, okay. Similarly yi minus y mean whole square 1 upon n yi whole square. One thing now one more term we are going to drive it. It is xi minus x mean with yi minus y mean. Now this becomes xi yi minus y mean xi minus x mean yi plus x mean y mean. One thing now this part becomes xi yi y mean with x mean with n times x mean y mean, opening the brackets. Now this becomes xi yi minus. Now to summation of xi, from here can we write it x mean with n, okay. So we are having y mean with n times x mean minus similarly x means with n times y mean plus n times x mean y mean. Xi yi minus n times x mean y mean minus n times x mean y mean plus n times x mean y mean. Now these two are the like terms. So what we are left with? We are left with now xi minus x mean times yi minus y mean is equal to summation for xi yi minus n times x mean y mean, or we can write it this as xi yi minus n times summation of xi summation of yi upon n times n. Okay, and one end will be cancelled. So we are left with xi minus x mean yi minus y mean is equal to xi yi minus 1 by n xi yi. Okay, this part. Okay, so now we are having three different things, 1, 2 and this part as a 3. Now substituting these in the formula. Now what we were having, x comma y or r, simply rho or r, one and the same thing, coefficient of correlation. Now we are having this as n I is equal to 1 xi minus x mean yi minus y mean upon square root of xi minus x mean whole square with yi minus y mean whole square. Now we are having three different terms. Number 1, this part. Number 2, this part, and numerator top part. Okay. So now this becomes, just substituting these parts, we are having now summation for xi yi minus xi yi upon n whole. Now this becomes xi square from here, this part. Is it clear? With similarly for yi square minus whole square upon n. Now to this further we can write it xy minus upon n upon or is equal to, now second formula for the coefficient of correlation without deviations. So we can write it now, after taking the LCMs we can get it n xy y upon with So, this is the desired result.